All right, so in 2.3, we're going to look at the Egyptian and Babylonian methods for division. And so we'll kind of jump right into the Egyptian for now. We'll get into synthetic division down the line. It's not included in this section, but it's technically falls in the category of division, but it kind of fits better when we start talking about quadratics. So we'll come back to it. All right, but the Egyptian method of division tied to the method of multiplication, because division is really just a special form of multiplication, where the dividend is a number that's being divided by another number, all right, which is known as the divisor. All right, so we start with two columns, just like we would for Egyptian multiplication. Form the left column with multiples of 2, so 2 to the 0th, first, second, and so on. All right, and the right column, we can head that with divisor. All right, so what we do is we account for the powers of 2 on the left corresponding with the divisor doubled again, until the next double would be bigger than the thing that you're dividing. All right, so the dividend. All right, once you get there, you stop. Don't include the one that's bigger than the number you're dividing. All right, not the number you're dividing by, but the number you're dividing. Once you get to that entry, then you stop. Mark off any values in column 2 that would add up to whatever that dividend is, right? And then whatever values you have in corresponding 1 would end up being the quotient. The quotient is the result of divisor divided by dividend. I can make a note of that here somewhere. So quotient is equal to dividend divided by divisor. Divisor as in thing doing the dividing, right? So let's say you had something like, and I'm stealing an example that comes later, but let's say you have 40 divided by 5, right? 40 divided by 8. I guess it would have been fine either way, right? So we have our two columns. The first column would be the powers of 2. So I'd have 2 to the 0th, 2 to the 1st, and so on. I don't know how far I'm going yet, because I'm going to double my 8 over and over again until I get to a number that's bigger than 40. So I'm going to start with an 8 here, 16, all right? So the divisor itself, divisor multiplied by 2, 32, that corresponds with 2 to the 2nd power. If I double it again, I get 64. Because 64 is greater than 40, we don't include it. All right, so the 64 is out. What we then do is look for any set of values that would add up to whatever the dividend is. So that's my target number. Out of the 3 numbers I have here, if I take an 8 and add to it a 32, 8 plus 32 is equal to 40. So I'm going to use these 2 entries. All right, that's a 1, that's a 4. 1 plus 4 is equal to 5, and so therefore 40 divided by 8 is equal to 5. All right. Now, if you know your multiplication tables, you'd be like, well, I already knew that, so what was the point? All right, it's more of an algorithmic approach, but it leverages your knowledge of multiplication to help you divide. All right, and so you can see all of this is sort of detailing that out. All right, and so it's a lot to kind of write. All right, we could also have cases where there might be a remainder. Right? They were well aware of division with a remainder term and represented it in fraction form, primarily working with unit fractions with the exception of 2/3. All right, all remainder terms were written using such fractions. All right, so for ease of computation, the remainder term in this section will be left as a number, so we'll just say remainder 2 or something. Using fraction form, is shown in the last topic of the unit. So we'll get there, but we do have to talk more about unit fractions before too long. All right. So we do the same stuff that we did before, steps 1 and 2. Right. We make our columns. If the sum of the marked entries in the right column is less than the dividend, calculate the remainder term, dividend minus the sum. All right. And then continue above with the remaining steps and write down the final answer with the remainder. So I'll just take you through this example here. 753, if you're doing that on a calculator, we'll just do it real quick. Decimal, all right, so we know we're going to get a remainder. We're looking for a target of 753. The problem is if I include one more value in the column, right, so again, I'll just kind of sketch it out on the side here. I have 2 to the 0th, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th. I'm multiplying by 26, so I'm looking at multiples of 26, doubling, so multiplying by 2 consistently. 104, 208, 416. If I double that, I'm going to get 836, which is bigger than my target number of 753, so I can't include the 836. But no matter how I add the values together, I don't get a number that would add to be equal to my target value of 753. All right. So you can try every possible combination. The best that you can do would be 416 plus 208 plus the 104, which would get me to 728. Now, if you're like, well, let me try putting the 52 and the 26 in there. 52, if I added on a 52, I'm trying to target 753. That's too much, right? Even if I added the 26, so if I said 728 plus the 26, it's still too big. It's only too big by 1, which is nice, but it's still too big, right? So I'll take the ones that'll add to a number that's less than my target value, all right? We take note of the values in the right-hand or the left-hand column that correspond with that, but in doing so, what we have to also account for is that remainder. So the way to handle that would be to take whatever your target number is, 753, and subtract off from it what the closest value to that number was by adding the values in the second column. All right, so we do 753 minus 728 gets me the 25. So now I know off the bat I have a remainder of 25. All right, so if I then only add the relevant values, the 4 plus the 8 plus the 16, I get a result of 28. That's these. So the 4 plus 8 is 12 plus 16 is 28. So I'll have 28 with a remainder of 25. Now, if you're comfortable with other forms of division, we would know that we would then take that 25 and divide it by whatever the divisor was, so 25 over 26. So we could make it a fraction, but like I said, we're going to kind of save that for down the line. All right. There's another example here. Let me just make another one on the fly here. Let's say you have 153, and we want to divide that by 15. So a number that I know will not divide evenly into it. So we take care of our powers of 2, so 2 to the 0th, 1st, 2nd, and so on. The 15, I'm going to double that, 30, 60, 120. If I double it again, I get 240. That's too big. So that's gone. Add up the relevant values. If I do 120 plus 30, that gets me to 150. But if I include any of the remaining values, I'm going to be too big. All right, so these are the only relevant ones. So I'll do 120 plus 30 is 150. 153 minus 150 to get my remainder. Then I would take these relevant values and add them together. So this one's a 2 to the 1st is 2, and an 8. So that gets me a 10. All right, so my answer, 153 divided by 15, would be 10 remainder 3. All right. So if you wanted to move on to the division portion of this section of exercises, you could. But I'm going to move on to Babylonian in the next